All right, so I often hear people say things like WebRTC is the only option or the first option for very low latency in the browser. Before we get to Meteor over QUIC, I'd like to go back a little bit. Back to 2018. In 2018, I was put on a project that changed the trajectory of my career. Today, I'm a principal systems engineer at Cloudflare, but in 2018, I was a DevOps engineer doing configuration management, and I was assigned to a project that was high priority. I was assigned to preemptively get the configuration management and the deployment automation in place for the launch of Limelight's real-time streaming platform. So we were going to build a platform for very low latency distribution at broadcast scale to browser clients. Can anybody guess why we were looking at doing this in 2018 specifically? So in 2017, Adobe announced that they would no longer be supporting Flash. They were moving to an HTML5-based platform. And many of Flash's features could be effectively replaced by web-native technologies. This is great. This is like a good thing. We are advancing. However, one thing was no longer possible with the demise of Flash, and that's RTMP for distribution. Up until that point, RTMP was an option, not just as an ingest protocol, but a distribution protocol. And RTMP could get live streams into your browser in under 5 seconds. So we had clients that depended on this. Right? They had very low latency requirements, and they had very large audiences. So we needed a solution. And at the time, the most viable option was WebRTC. So technology can provide value, but only within a given context. And when that context changes, the value that that technology is able to provide also changes. Right? At one point in time, RTMP was viable as a distribution protocol for very low latency. That's no longer possible. The world has shifted, things have changed. And when things move on, the nexus of activity changes too. Right? The people involved in standardization efforts, the people involved in implementations, interoperability, maintaining these ecosystems that we require to do our work, they move on. And that happened with RTMP as well. Right? So RTMP being a proprietary protocol also suffered in that the spec was not easy to update. Until just recently, we managed RTMP-E. But until that point, it was stuck for a very long time with limited codec support, not being able to add new features like multiple tracks. And that's a result of the world changing, the amount of activity going into that protocol development shifting. So is WebRTC still the only option for low latency delivery to browser clients? You can probably guess. The answer is no. There's a new browser API available now called WebTransport. And WebTransport is similar to WebSockets in that it's an HTTP connection at first, and it gets upgraded. And that upgrade allows you to kind of get down to a lower level and access. In the case of WebSockets, it's effectively a TCP socket. You can send messages on at a fairly low level. In the case of WebTransport, what's exposed is actually the affordances of QUIC. And QUIC, if you're not familiar with the protocol details, has a few nice features, particularly for media. It has the ability to make lightweight multiplexed streams. It has the ability to prioritize those streams. It has the ability to cancel those streams from either end. It offers encryption by default. And these features are now available to browser applications. So this allows us to do things that we can't do with TCP-based protocols, where we suffer from head-of-line blocking. Right? So in TCP, and this is why RTMP's latency is limited, when the pipe gets full, you can only put so much data in there before you have to wait and flush things through the system before you can send more. When you have stream multiplexing within a single connection, you can do things like start sending your next group of pictures on a new stream. And if the old stream has experienced congestion, you're waiting on retransmissions, then you might want to cancel it. The client could say, this is no longer useful to me. I'm skipping ahead. I would like to stay closer to the live edge. I don't need that data. We can free up bandwidth and move on. So how can we use this for media? One option would be that we all go and make our own proprietary protocols. There's probably some of this happening. Another option is that we could pool our resources. We could work together and develop an open standard that we could all share. I happen to think that the second option is a better option and leads to a better internet. So, to that end, at the ITF, there's a working group in motion now. Started in 2022. And we've been working on something called Media over QUIC. What are we trying to do with Media over QUIC? We're trying to achieve kind of the best of both worlds. We want to take some of the properties of live streaming as it stands today, and some of the properties of real-time interactive media as it stands today. So live streaming today with HTTP-based delivery and CDN support gets us economies of scale, gets us massive scalability, lower costs of delivery, but it struggles to achieve very low latency. Real-time protocols like WebRTC allow for that interactivity, but have traditionally been tuned for exclusively interactivity and don't always give us the trade-offs that we want for broadcast quality media. So this chart is a little bit of a simplification. Actually, my arrow broke in the conversion. I didn't notice that. But the gist here is that with Media over QUIC, we can provide a protocol that allows for the whole gamut of latencies and allows us to choose a point on that curve which is optimal for our use case. Okay, so you might be thinking, okay, this sounds like an impossible undertaking. You're taking the communications world and the broadcast world, two completely different worlds, and you're smashing them together. And you would be right, this is extremely challenging. It's not challenging so much for the technology. The actual engineering to meet these requirements is doable. The hard part is really that the requirements for communications, the requirements for broadcast, the people who know those requirements inside and out are steeped in their respective domains. and they have their own language, and they have their own unstated assumptions. And so a lot of the work that we've been doing within the Media Over QUIC working group has been unpacking those assumptions and making sure that we're not talking past each other, that we can get down to the fundamentals and figure out what it is that we share, right? Like, these technologies share things in common, and by factoring out those shared pieces, we can benefit by sharing a lower level protocol and building infrastructure to support these use cases. Okay, so this is a simplification, again, of the current media landscape with protocols. This is taken from a slide from Ali Begin, and it basically describes HTTP-based delivery mechanisms, the traditional ones. You're looking at latencies upwards of 10 seconds. There are some newer approaches, LL-, LLHLS, which get down below that, maybe even approaching 1 second in good conditions. And then you have WebRTC, which is kind of centered around 100 milliseconds, trying to get very close to real-time latency so that you can communicate with people, right? You want to be able to carry on a conversation with somebody, and that requires, as little latency as possible, and a prioritization of audio to be able to carry on these conversations. But there's a gap here that I think people are becoming familiar with, a gap that's felt by sports broadcasters, a gap that's felt by auctions, a gap that's felt by any kind of interactive media where you have interaction with your audience. And it's this kind of ultra-low latency space, the gap between HTTP-based delivery and what you can do with WebRTC. And so Media Over QUIC is initially targeting that gap. Not everybody in the working group is focused exclusively on this use case. Cisco, the WebEx folks, are obviously focused on replacing WebRTC for conferencing use cases. So Media Over QUIC as a protocol is capable of expanding potentially across this whole field of use cases, but we want to focus on something where there's a real need, where we can provide value first. All right, so where do things stand with Media Over QUIC today? First of all, the architecture. In Media Over QUIC, you have a publisher and a subscriber. And you open a connection between them using either web transport or raw QUIC. In the browser, it'll be web transport. That's the only option. The roles are interchangeable. Anyone can be a publisher or a subscriber. But the first thing that happens is an exchange of setup messages. And that sets up a bidirectional stream for control messages. That's the blue here. Once that control message channel stream is set up, then the subscriber could send a subscribe message, subscribe to a track. And once that track is subscribed to, the publisher can send the objects of that track on one or more streams. And so this allows us to do things like preemptively begin sending the next GOP on an independently delivered stream in case we want to prioritize things differently to cater to our latency requirements. And that's the gist of it. But importantly, by making this an open standard, it means that we can also have relays in the mix. And a relay is really just a publisher and a subscriber. It proxies the subscription requests to an upstream publisher and sends them downstream, which is useful if you want to fan out to large audiences and achieve the scalability that we're talking about. Okay, the Media Over QUIC object data model looks something like this. Within a namespace, This namespace is BBB for our favorite bunny. And within a namespace, you have tracks. Those tracks contain objects, and those objects are organized into groups. So here we have a track called .catalog, a track called 1.m4a, a track called 1.mp4. So a subscriber could subscribe to BBB 1.m4a and get the audio that's being produced. Or it could first subscribe to .catalog and get relevant metadata about the media that it's about to consume. Media over QUIC transport, the specification, does not specify the mapping of media into those objects and groups, and now subgroups, which we'll talk about in a minute. That's left to another layer. So this is a characteristic that distinguishes media over QUIC from WebRTC. WebRTC has kind of all the pieces that you need all glued together fairly tightly. So it's a bunch of different protocols, but you're dependent on things having a way to be described in RTP, for example. If you want to use a new codec and you don't have a way of describing that in your SDP, you're going to struggle to shoehorn it into WebRTC. With media over QUIC, we have taken a very layered approach and said, okay, we're going to have an abstraction here where the relays shouldn't have to care about what is in the objects in any way. That's left for the application layer, or in this case, you can standardize it with a streaming format. Warp is an example of a streaming format that Will Law has been working on specifying. Okay, so what's new? I mentioned subgroups briefly. So subgroups were added in draft 6, and subgroups are kind of what they sound like. It's another unit of subdividing objects within a group. But subgroups have the useful property of mapping directly to streams. So subgroups are a way of hinting to relays that this is how I would like things delivered. Because of the properties of my media, I would like things ordered, that are grouped together. And I would like them to be subdivided in this way. So groups represent join points in media over QUIC. So when you subscribe, you typically would say, I would like to subscribe next group. And at that next group boundary, you get object 0, which would be something like an iframe. It's a point that you can join, whatever your media is. It may not be even video. But subgroups allow us to do things like take layered codecs and deliver them with different priorities. So you might have media that's in the same group, but because of their different layers, you might want to deliver the base layer with a higher priority. And subgroups allow for that. Fetch is a new feature that basically comes out of clarifying things, clarifying that subscribe should deal only with the future. So as a consequence, we now have a concept for fetch, which deals with the past. And fetch is a lot like an HTTP GET. In fact, I suspect that as people begin to implement more fetch-capable relays, a lot of it might be using HTTP GETs behind the scenes. But it allows you to access objects from the past. As a consequence of drawing this sharp line between past and future with subscribe and fetch, it made sense to also define something called joining fetch. And this is kind of the convenient case where I would like to join at whatever point in the current group that things stand, but I need object 0. I need the iframe so that I can decode things. So give me the current group starting from the beginning of it, plus everything moving forward. And that's what joining fetch is for. More recently, we've defined relative joining fetch, absolute joining fetch. These allow for things like ABR switching. So you can say, at this point in time, I would like to switch to this other track. I would like to initiate a joining fetch here. We also clarified prioritization. Prioritization is complicated. So we've been working on that a lot. And there have been many additions to the warp streaming format and the catalog draft. So it's starting to include all of the things that you might expect from something like HLS or Dash. There's also a new media interop draft, mock.me, that actually Jordy, who's here, wrote that. And the idea there is to provide a simplified subset of capabilities that we can interop on using real media. And so we have some interop testing that's happening now using mock.me. The newest thing that will probably be in the next draft is publish. So I mentioned subscribe is how you get access to tracks. Well, publish allows publishers to preemptively start sending objects without having a subscription. So publish says, may I send you some objects? And if the subscriber on the other end says, yes, go ahead, then you can begin sending those objects. And this allows for kind of the ingest use case to be a little bit cleaner. So rather than having to pull through with a subscribe all the way from the end before you can start sending any media, you can publish to your ingest point or your relay network or whatever. The other exciting new things are a lot more implementations. So we have actually more than just this list, but we have more than 10 open source implementations. We also have mock support in the Norsk media engine. Ivan has been experimenting and building some testing tools and frameworks. And Vindral, who I believe also are here, have in fact already converted some production workflows over to using media over QUIC, which is pretty exciting. Also, I am from Cloudflare. I'll probably have some more news to share soon. So, mock may not be the first protocol to target low latency in the browser, but it doesn't have to be valuable. Mock can build on everything that we've learned from the past and provide an open standard so that we can come together and mutually benefit from work on improving these use cases. There are some things working in favor of mock success, but there are also headwinds. So two of the biggest risks I see are complexity in the current draft and the rate of change, making it hard to maintain interoperability. So I think that as we see these implementations going out into the world, those things will address themselves. People will kind of latch on to the set of features that they need, implement those, interop on those, and then we'll take that feedback back into the draft and simplify and prioritize and focus. So I'm excited. I think that this is the year of mock meeting the real world and that feedback coming back into the working group. We're probably halfway through the process of getting mock to an RFC. That might even be optimistic. Standards take a very long time. But that doesn't mean that we can't start experimenting and shouldn't start experimenting, because the more of that we do, the faster we can get everything aligned with what is actually needed in the real world. Thank you.